Hi everyone. So what we are working on today will be solving systems of equations, linear equations by graphing. And so our goal is to be able to solve systems of equations using graphing and also to analyze some special systems. So before we begin, what is a system of equation or system of linear equation? So linear system is composed of two or more linear equations. So in our case, we'll just be working with two different linear equations, all right? And so when we talk about the solution of the system, it is a value of the x and y. It's an ordered pair that makes all of the equations in the system true. So if there are two equations in there, whatever x and whatever y you put on one equation, it should also make the second equation true. So that's what we call as a system. And so let's have an example here, all right? So as you can see, we have two equations here. Y is equal to x plus 2, and the other one is y is equal to 3x minus 2. So first thing that we have to do is make sure that we graph each line, all right? So let's use blue for this line here, and I will use red on the second line, okay? So our equation is in slope-intercept form, so it's easy to graph. Y, this is our first point, plus 2. So we know that we will have a point at positive 2. And our slope is 1 over 1. So the slope is 1 over 1. So it goes 1 up, 1 to the right. So we will have our next point to be over here. Oops. Okay, it's going to be over here. Okay. Now, we can connect those 2 points to create our line. So that's how it would look like. All right. Now let's change our ink color and change it to red this time. Okay. So our next line is, first point is at negative 2. So that would be negative 2 is going to be here. Okay. And our slope, as you can see, is 3 over 1. So it means we have to go 3 up, 1, 2, 3, and then 1 to the right. It's going to be on this point. And so if we graph our line, that's how it will be. Now, looking at our graph now, okay, since we are looking for the solution, all we need to look for is where the two lines intersect. And do we see any point of intersection? Definitely we have, all right? As you can see, let me just highlight that point here. You will notice that those two lines intersected, at this point over here. And what is that point? That is 1, 2, that is 2. And that will be 1, 2, 3, 4. Okay, they intersected at 2, 4. Now, how can you make sure, how can you confirm that this 2 is our solution? You can replace our x and y value into the equation. So, for example, in y is equal to x plus 2, the y value is 4. Is it going to be 2 plus 2? Definitely. All right? You can check it with the other one. So, y is equal to 3x minus 2. Our y value would be 4. Will it be equal to 3? Our x is 2 minus 2. So that's 3 times 2, 6 minus 2, that's 4. So 4 is equal to 4. So as you can see, if your x is 2 and your y is 4, both the equations are true. So that is how we solve systems of equations by graphing. We graph the two lines and look for the point of intersection. Okay? So let's have our next example. This is now our next system. We have 2x plus 4 and negative x minus minus 2. Graph the two lines and find the point of intersection. Go ahead. All right. So if you graph your lines, okay, again, I use two different colors here. You will have this line, the blue line is the 2x plus 4. This red line is our negative x minus 2. So that's that. And so you will see that they intersected at negative 2, 0. Okay? All right, so let's have our next example, and this time it's going to be in word problem form, okay? So as you can see here, we have scientists who studied the weights of two alligators over 12 months, all right? The initial weight and the growth weight are given here at the bottom. So we need to find how many months will the alligator weigh the same, okay? So we need to find an intersection, all right? So let's have our first alligator. We have an initial weight of 4 pounds and a rate of growth of 1.5 pounds per month. So because of this, so let me just use our ink. Okay. So our rate of growth, this is definitely our slope. And the initial weight, that's when it was born. So none of the months have flown by yet. So this is our y-intercept. So from here, we have an equation that is y is equal to 1.5 pound. So 1.5x plus 4. Okay, same idea with our second alligator, same scenario, okay? Just this time, it's going to be written as y is equal to, the slope is now 1, so that's just x, plus the initial weight, which is 6 pounds, all right? So let's graph these two equations here and see at what point will they intersect so that we know that is the number of months that they have the same weight, okay? So let's label our graphing area here. Horizontally, this is the number of months, okay? So I'll just use, so this is 0, 1, 2, 3, 4, 7, 8, 9, and so on and so forth. And then vertically, this is the weight. Okay, now I don't have enough space here, so I'll just use by 2's as the label here. 2, 4, 6, 8, 10, 12, 14, and so on and so forth. Okay, so let's graph our blue equation. That will be our point, our y-intercept is at 4. So we will have a point at 4. I hate it when that menu shows up a lot. So we go at 4 and then we move by 1.5. Now, it's kind of a little bit difficult if we're going to do how are we going to jump by 1.5. So just imagine replacing our x by 2. Why? Because 1.5 times 2 is going to be 3. Okay? So when your x is 2, your y value will be, 1.5 times 2 is 3. 3 plus 4 is 7. So when your x is 2, your y value is going to be at 7. Okay? And then, if you have a y that is equal to 4, all right, what will be the value now of your, if your x is 4, that's going to be a 1.5 times 4, which is 6, plus 4, it's going to be a 10. All right? So we can use those points for the meantime, and you will see that the graph will be like that. Okay? Now, let's have our next graph, which is the red equation. Our y-intercept is at 6, so we start over here. Okay? And it needs to go up by 1 over 1. So it's always 1 over 1. So when it is 1, it will go to 7. When it is when it is 2, it will be at 8, and so on and so forth, all right? And you will see that the line will be like that. And so, can we see a point of intersection? Yes, okay? You will see that both lines intersected here when, and what was that? At 4 months, both alligators weigh 10 pounds, okay? So at 4 months, both alligators were weighing 10 pounds. Okay, so that's how you can use your systems of equation on problem form like this. So why don't you try this next example on your own? Try and find in what month was the cost of the service the same. Go ahead. All right, so for this problem, we have our two equations, $10 per month. So that's our slope, 10x, and then the activation fee is our y-intercept. So our equation was 10x plus 20. And then the second service, same scenario, 11x plus the $15, which is the initial fee. So if we're going to graph the blue, that would be a first point at 20, and then every time you move a month, it adds by 10. So the next point will be at 30. Okay. For the y, it's a little bit tricky because we have our point of our y-intercept at 15, which is easily to find. But the next point, as you can see, if it is 1, this is going to be 26. So it's a little bit challenging to have it, especially if your graph is in, how do you call this? In a smaller version. And so what you can do is you can look for an exact point. Now in this case, I selected 5. Why? Because 11 times 5, that's gonna be an exact value, which is 55, and then you add to 15, that's gonna be a 70. So I have 5 and 70 over there, and you can see that they actually overlapped at that particular point. They are actually intersected at that point. So what does that mean? After 5 months, okay, both the services, both the radio service will be able to charge $70. Okay, so that is when both services have the same price. Okay.